Good morning, good afternoon, and good evening, wherever you are. Welcome to the Tech Talk series. Today we're covering end-user computing. We're going to be discussing enabling secure desktop access for government organizations using smart cards. Our objective for today is to learn about what Amazon end-user computing is. We'll understand what Workspaces is and do a demonstration of Workspaces with CAC card. We'll understand AppStream 2.0 and the requirements around AppStream 2.0 with Smart Card with a demonstration. Joining me today is Adam Hesh. He's a senior federal system integrator solutions architect with our worldwide public sector team. And I'm Julia Smith. I'm the Global Business Development Manager for End User Computing with our worldwide public sector team. What is Amazon Web Services End User Computing? It's comprised of two main products, Amazon Workspaces and Amazon AppStream 2.0. Our mission is to deliver the ability to securely get work done from anywhere, from any device. End user computing is comprised, and customers go to end user computing for four main reasons. First and foremost, we help customers increase security. At AWS, everything we do starts with security. And the AWS cloud and our end user computing services are built for the needs of our most securely focused customers. Secondly, we help customers increase agility. Organizations need to scale up and scale back in minutes, and they need to move their end user computing power to anywhere in the globe overnight. Thirdly, we increase reliability. We have a global scale and are available everywhere, and we have a 99.9% uptime SLA. Fourthly, we help optimize costs. Because we run in the cloud at scale, we can keep our infrastructure costs low and pass them on to our customers. And of course, the entire point of this is that we enable our customers to empower positive and productive users. With Workspaces and AppStream, our customers get the experience they need, and they get their job done from anywhere. So Amazon End User Compute is comprised of Workspaces and AppStream, as we discussed. Workspaces is our fully managed persistent solution, and it's a cloud-native desktop. It's meant to replace your desktop and laptop, and it's configured as a desktop or laptop would be configured. You choose the processing memory that you need based on your compute needs for it. And persistent means every time you log in, it's the same instance every time. It's managed like a desktop or laptop and deployed by the named user. AppStream 2.0 is our fully managed application and desktop streaming service. It is non-persistent. And what that means is that every time you log in, it's a different instance that you log into. That means that when you move things around, they don't stay. Only the administrator can make changes on the image, and it is managed like a kiosk. AppStream 2.0 is accessed through an HTML compliant browser. Okay, moving on. AWS supports more security and compliance standards and provides more auditing and reporting tools than any other public cloud. We help satisfy compliance requirements by virtually every regulatory agency around the globe. On the left, there's a list of key certifications our customers inquire about, and these give organizations security, compliance, and risk teams peace of mind. In fact, we have over 200 compliance and security standards, and there's 40 more than our nearest competitors. A comprehensive list of these can be found on our website. Okay, so now let's turn and talk a little bit about end user computing and why it's different than any of our competitors out there. The biggest differentiator is our fully managed cloud native architecture. It enables us to deliver virtual applications and desktops at a global scale with the reliability and security customers demand. So taking a look at the graphic, we see that AWS owns everything except the base image and policies. By abstracting away these infrastructure layers, IT no longer has the burden of performing undifferentiated build or maintenance activities. And procurement no longer has to go through the laborious process to add infrastructure or to go through procurement, which typically takes anywhere from 12 to 16 weeks. Amazon End User Compute Services help organizations protect their sensitive and valuable data, coupled with strong authentication integrations and secure access measures. In fact, device certificates and multi-factor authentication ensures strong authentication measures are enforced. We'll dig into the CAC and PIV a little bit later and see a demo shortly. And now I'm going to turn it over to Adam to dig into Workspaces and AppStream and show us a demonstration.
Thanks, Julie. So now we're going to talk about Amazon Workspaces, our persistent desktop virtual desktop infrastructure service. So specifically, the requirements that are necessary to deploy either DoD common access cards or federal government personal identification verification cards, or CAC and PIV as they're otherwise known, are fairly consistent with Amazon Workspaces. The first thing you need to start with is a secure baseline for which your images are going to be based off of. That usually starts with a secure host baseline, which is normally provided by the government to enable you to deploy certain sets of requirements and security checks that are necessary, as well as any bring your own license endpoint verification software. So host-based security, antivirus, things like that. The next component of security that's necessary is going to be setting up, configuring your Active Directory to conform to your specific service requirements, as well as having a third-party certificate authority, which your smart cards and PIVs will be based from, and then any group policy necessary to meet your particular compliance requirements. Once you have security configured for your workspaces, you're then going to need to actually enable smart card authentication for them. We consider smart card authentication to consist of two different features. We have our pre-session authentication, which is the act of logging into the remote workspace or AppStream instance from your local desktop, as well as in-session or pass-through authentication, which is once you're inside of your workspace, the ability to use that common access card or PIV card to get access to websites or applications that you may need to conduct your day-to-day business as part of VDI. The next piece of Amazon Workspace configuration is the client operating system component. While Workspaces in general supports almost every operating system you may use, CAC and PIV pass-through and smart card pass-through is limited to just Windows currently, as well as our Macintosh OS. The remote workspace operating system is also limited to just Amazon Linux and Microsoft Windows. In order to configure Active Directory for smart card authentication, the first step you'll need is to have a third-party certificate authority to use. That can either be one bought from a commercial provider or one hosted locally in Active Directory using Active Directory certificate services. Another option would be using an existing third-party certificate authority, such as DoD CA, which would allow you to use something like DoD install root to install the necessary certificates for smart card authentication. Once you have certificate authority to issue your smart card certificates, you'll then need to configure Active Directory to support it. That's going to consist of a couple large steps. You're going to have to configure your AWS Active Directory connector to actually connect the Active Directory implementation to AWS and to Amazon Workspaces. You're going to need to configure your alternate UPN configuration within Active Directory to match what is put on your smart cards of your user identification. And then you need to apply any DoD or otherwise group policy that is necessary to make those certificates available on the endpoints. Now that we've gone through some of the requirements for how to set up Active Directory certificate and for certificate authorities, let's look at the networking for Workspaces that makes all this work. So the way that Workspaces operates is that your end user at point 1 will connect to the Workspaces endpoints over the internet, and that will connect to AWS's public workspace endpoints. The first step is you'll open up the browser that will then connect to the authentication gateway, which will prompt your user to select their certificate and respond to a challenge that will prove that the authenticity, that they own the smart card and that they have access to the private keys stored within. Once they respond to that challenge, the authentication gateway will then reach out back over the internet to the OCSP responder associated with your certificate authority to validate that the smart card is still and certificate contained is still authenticated and authorized and has not been revoked. Once revocation status has been determined, the authentication gateway will log the user into Workspaces and connect them to the appropriate streaming gateway. And the streaming gateway is what provides a connectivity between your user and the remote instance that's providing their workspace. The instance itself is hosted inside an Amazon Workspace VPC that is a fully managed private VPC run by Amazon. The way that it is instantiated in your customer VPC is through the existence of an Elastic Network Interface, or ENI, that persists within your customer VPC. The great thing is that Workspaces enables you to use the common networking and security controls you're used to in AWS to provide network and security controls for your workspaces. So things like security groups and subnetting are all part of your workspace configuration and can be built into your security of your VPC. One requirement for configuring Workspaces, as you see, is the requirement for an Active Directory connector. What this is a bridge that connects between either your on-premises Active Directory through Direct Connect or VPN, or your Active Directory that's configured within your customer VPC. That will provide the directory and do the domain joining for your workspaces as they are spun up and spun down. Once your user is connected to their remote workspace, they then have access to any resources you see within the customer VPC, file shares, application servers, web servers, or even the public internet. At point 3, the internet connectivity for Workspaces is provided by your customer VPC, which gives you discrete control over what websites and what services your customers are allowed to access. You can place something like a reverse proxy or a web proxy in front of those and tightly control what websites your users have access to. Now that we know the requirements to set up Amazon Workspaces and we've seen the networking associated with it, let's see this in practice with our demonstration. What we're going to be showing today is we're going to launch an Amazon Workspace using our client. The client is a requirement to enable smart card pass-through into the session. We're going to use our CAC to log in. It's going to validate my certificate against the DoD's online certificate responder. It's then going to authenticate me against our Active Directory instance and log me into my remote workspace with my user credentials tied to my common access card. Now that we have the Workspaces client open on our desktop, we're going to select to insert our smart card. It's going to prompt us to select the appropriate certificate from our smart card. It's now going to prompt for the PIN to unlock the private key associated with that certificate. And it's sending back a challenge response to the Workspaces service and then authenticating against our OCSP responders. Workspaces has to do that last check, otherwise it will not allow the user to get access to the workspace if it can't validate the validity of the certificate. The second prompt for a PIN is actually to provide a PIN to log into my remote workspace session. This is a requirement for Active Directory domain workspaces instances that have smart card authentication. Now we're going to wait a few moments while it connects from my local session to the remote workspace. While we're doing so, we're going to talk a little bit about some of the benefits of smart card integration in terms of workspaces. Workspaces allows you to have smart card integration into your workspace with no additional configuration outside of Workspaces itself. It's built into the client for both pre-session and in-session authentication. and simplifies the process for starting up your smart card authenticated workspaces. Now that our workspace is ready, let's go ahead and try and use our CAT card in the session to demonstrate that it is being passed through from my local desktop to the remote session. We'll open max.gov, which is commonly used by the federal government. We're going to log in, and we're going to opt to log in using our CAC or PIV card. And just as if I was working from my home computer, it's going to prompt me to select my certificate within the remote session. Enter my PIN in to prove my authenticity. And connect me into the service. So another common use case for Workspaces is actually as a bastion host for administrators and developers. I'm now going to use my remote desktop software to connect to the local domain controller. It offers me immediately the option for username and password, but additionally, since my smart card is available within the remote session, after a moment, it'll be giving me the option to select that, enter my PIN again. Now I can perform remote desktop administration of servers within my environment without having to expose it through traditional things like remote desktop gateway or other virtual desktop infrastructure options. This is a really powerful way to abstract your administrators from the environment that the production servers are living in. As you remember from the architecture, that streaming gateway is the only connectivity between the end user and the workspaces. So you can have a completely private VPC with no external connectivity. Your administrators are able to go in and perform their administrative duties with. It'll take just a moment to get logged in with our session. And here we go. And again, now we're able to go in and remotely administer our domain controller, all from within the security of our workspace through streaming pixel services. And with that, let's go back and talk about AppStream 2.0. AppStream 2.0 is our non-persistent virtual desktop service. Very similar to Workspaces, you're going to have some requirements that are going to need to be configured to set up AppStream 2.0 for smart card integration. Security, you have the same requirements for secure host baselines and endpoint protections that were present with Workspaces. Although optionally, you have the ability to you do not have to configure a customer Active Directory, certificate authority, or group policy. One of the big differences between Workspaces and AppStream 2.0 is the ability to use any SAML identity provider for your pre-session authentication into Amazon AppStream 2.0. This gives you the option of either configuring Active Directory and using Active Directory Federation services for login by pre-session, or you can use any third-party IDP that supports CAC authentication, such as Keycloak, Duo, Okta, or any of our many partners. Going down into the authentication piece, you also have the ability for in-session pass-through from the client to protected sites using the AppStream 2.0 client. Alternatively, if you prefer not to have the AppStream 2.0 client on your endpoint, you can use an HTML5 compatible browser to get access to AppStream 2.0. In that scenario, you will not have access to the local smart card, but you can still perform pre-session smart card authentication using any supported identity provider. Another differentiation between AppStream and Workspaces is AppStream currently only supports Windows, both on the client operating system, so what you're connecting to AppStream from, as well as on the remote desktop. Only Microsoft Windows is supported. But again, you do have the option of using the HTML5-based web endpoint for AppStream, which gives you the ability to support any type of device you prefer. Go into the networking associated with AppStream, you'll see that we have a lot of similarities and a few differences. With AppStream 2.0, your users have the option to connect either over the public internet to the public endpoints or via your VPN or direct connect to a private VPC streaming endpoint. Additionally, when our user connects to the streaming gateway, the first thing they're going to do is be redirected to our third-party identity provider. In this case, I'll be demonstrating the use of Active Directory Federation services. I'll log in with my smart card to ADFS. ADFS will then return a a SAML token that is going to authenticate me against the AppStream 2.0 service. Now that I've been authenticated against AppStream 2.0, that streaming gateway will then connect me to the fleet that's associated with my AppStream stack. That fleet, just like Workspaces, will persist itself into the customer VPC through a network interface that, again, has similar security controls such as security groups, subnetting, to control discrete access to your access services. AppStream 2.0 is connected to your domain if you choose to domain join them through standard service account login into the domain. So as the fleet is spun up, it's domain joined via that service account. There's no need for the Active Directory connector. And again, internet connectivity comes through the customer VPC, so you can tightly control access to the internet and what sites your users have access to. Now that we know the network flows associated with AppStream 2.0, let's talk about the demonstrations we're going to do. The first demonstration is going to be a domain-joined AppStream 2.0 using the client on my local desktop application. As I mentioned before, that'll give me the ability to connect to it remotely with my smart card, as well as use my smart card within the session to authenticate to federal government sites. The first step is I'm going to launch the AppStream 2.0 client. I'm going to then be actually selecting the identity provider endpoint associated with my particular IDP. I'll do the login process with ADFS. Then I'm going to be prompted to authenticate against the Active Directory that is being joined to that instance. And then I'll be able to select the application or desktop view that's been assigned to my AppStream 2.0 stack. The second demonstration today will be connecting to AppStream 2.0 to a non-domain joined instance via an HTML5 compatible web browser. The first step is I'll put in the web address for my identity provider. Again, ADFS in this scenario. I'll complete the identity provider login process. I'll select the AppStream 2.0 application or desktop view of my choice, and then I'll have the ability to interact with that remote session strictly through the browser. Let's go ahead and look at the demos. Now that we have the AppStream client open, we hit connect to the identity provider endpoint that we have specified. Now my identity provider will prompt me for my authentication. Select the appropriate certificate. Enter my PIN to the challenge. And now after I've entered my PIN, the identity provider is redirecting me to the AppStream 2.0 service. Since this is the domain joint instance, I'm now getting a second smart card prompt, which will allow me to select the certificate and enter the PIN to log me into the Active Directory identity that's been configured for me. And it's now going to connect me into that remote session. One of the advantages of AppStream 2.0 is AppStream 2.0 is a streaming pixel service that's actually displaying images that are projected from the remote session to your local desktop. This is incredibly bandwidth friendly as the AppStream 2.0 protocol is smart enough to know when pieces of the screen have not changed. So if you're sitting and looking at an idle web page, what you'll see is that AppStream 2.0 is using very little data, only sending updates to the parts of the screen that have actually changed. This is very bandwidth friendly for things like learning sites and classrooms that may have limited connectivity but many users, as AppStream 2.0 has minimal bandwidth if users are on static sites such as reading email, looking at websites, or working on documents. Now that I'm connected in, you can see I have access to my AppStream 2.0 desktop, and I'm able to open my web browser, just as we saw with Workspaces. We'll go to max.gov, just as we did before, and we'll use our smart card to authenticate. AppStream 2.0 is a very similar user experience, but again, the difference being that it's a non-persistent service. When I log out from this particular session, will be recycled. Users are able to maintain things like their browser history as well as their desktop and any bookmarks in their browsers through the use of persistence, which is a setting that's configurable by the administrator. That's my client domain join instance, and we'll come in and we'll look at my identity. And we can see that I'm actually associated with my PIV identity into the domain. Now let's go ahead and do a demonstration of browser-based HTML5 CAC and smart card authentication for AppStream 2.0. Now we're going to use Google Chrome to connect to the AppStream 2.0 HTML5 based endpoints. This allows me to use AppStream 2.0 on any computer or device that I prefer that has an HTML5 compatible browser. The trade-off being I won't have access to my local devices like my CAC card or USB. So we will enter in the address for our identity provider. ADFS in this case is going to prompt us for select our certificate. We'll then be prompted for the PIN to prove that we have valid ownership of that certificate. And ADFS then logs me into AppStream 2.0. In this case, I'm given the option to select either application streaming with Chrome or Google Code, or desktop streaming where I have access to the full desktop. We'll do the desktop in this case. Now AppStream is connecting me into that remote session, and it'll take just a minute. The streaming capability for AppStream 2.0 allows you to grant knowledge workers, either from home or from unmanaged devices, easy access to AppStream 2.0 without the need to install any clients or configure any settings on their local endpoint. All they need to do is type in a web address that you provide, and then they'll be connected in. And additionally, the ability to have SAML as identity provider allows you to have different authentication points for different types of users. Perhaps corporate users or people who have a day-to-day access to your system will use something like a smart card or a PIV that's been granted by your organization. But if you have temporary workers or seasonal workers, this gives you the ability to use a third-party identity provider or just plain old username and password with time-based tokens to give them a different set of authentication. AppStream 2.0 also additionally gives you the ability to tightly control what those users do or do not have access to resource-wise within their session. You can control the ability to both copy and paste inside and into and out of AppStream 2.0, as well as the ability to upload or download files. All of those can be controlled on a one-by-one basis, meaning you can grant people the ability to paste files in or upload files, but not download or remove anything from AppStream 2.0. Now it's applying my application settings specific to my profile, and we'll be right into our desktop in just a moment. AppStream 2.0 additionally offers the ability to operate with multiple or single monitors in windowed or full screen mode. So it looks a lot like our previous client-based AppStream 2.0 implementation, but as you'll see, as I go to max.gov, as I'm working from the Chrome browser instead of the client, I'll no longer have access to my local certificate in that remote session. Benefits of this is, again, I have access from any type of device that I may prefer. Now that we've seen the capabilities of both Workspaces and AppStream 2.0, we'll go ahead and hand it back over to Julia to wrap things up.
Thanks, Adam. And now let's talk about how to implement these solutions. AWS has a competency partner network with consulting partners specializing in AWS end-user computing services. These partners provide services and offerings around the world to help customers with strategy, professional services, managing infrastructure, repeatable intellectual property, and optimization of end-user computing technologies on AWS. More information can be found on our website. So we have a few additional links that we can leave you with more information. And as a couple next steps, you can schedule an AWS end-user compute deep dive on your use case You can connect with AWS End User Computing Competency Partner, or you can schedule an AWS End User Computing Immersion Day with your account team. Thank you so much for attending our session today. We hope you found this information valuable, and we look forward to hearing from you. And now we're going to open it up for questions.